Hi, look what I got in the mail. The revised PCBs for the 486 socket blaster. These are revision 0.2. This revision not only fixes the issues of the previous one, but it also accepts two types of voltage regulators. I am going to assemble this using the same technique as in the previous video, but this time I will be a bit more careful and trying to get the headers cut as nicely as possible. So this time I will try to cut the headers using a box cutter. I think it's slightly better than using a wire cutter because we are getting a slightly cleaner cut. We need to make sure that the cut is clean and does not extend beyond the original ridge, because that can prohibit the headers from staying upright when placing them on the board. So I'm using a small file to smooth out the rough edges. Okay, the headers are now ready, so let's start soldering. Just like in the previous video, I'm placing them in a spiral pattern. Please make sure that all the solder joints are good before moving forward. You can also check for continuity between the top and bottom pins. There should be continuity between all pairs of pins except for the VCC ones. And for those, you can check with the input and output pads of the regulator. Now let's add the header for the CPUMUL jumper. We will test it later in the video. Please pay attention to the polarity of the voltage regulator. There is usually an arrow pointing from the input to the output, and the paths are clearly marked with plus and minus. Now let's set the voltage by turning the potentiometer. The socket blaster has this very convenient header that exposes the input, ground and output rails. This can be used not only for voltage monitoring, but also for attaching an external power supply or voltage regulator to power the CPU externally. The output of this voltage regulator seems to be going in steps. If I am at 2.9 volts and turn it a bit more, I'm getting 3.6 volts. There's nothing in between. I am setting it at 2.9 volts, but even if it drifts to 3.6, I think it should be safe. The 486 CPUs can usually accept voltages in the range of 3 to 3.6 volts. Let's insert the CPU and boot the system. And yes, we are getting postcodes, and the voltage stays at 2.9 volts. Now let's take a closer look at the CPUMUL header. This header can be useful for reducing the speed of a DX4 or an AMD 5x86. There are two jumper positions, 1-2 and 2-3. In 1-2, the multiplier is set by the motherboard. This would be 3x for a DX4 and 4x for the 5x86. Position 2-3 reduces the multiplier to 2x for the DX4 and 3x for the 5x86. Let's check if it works. I'm running the system with the jumper on position 1-2. This should be the default 100 MHz. And yes, it works as expected. Now let's switch the jumper to position 2-3 and try again. And yes, we're getting 66 MHz. On the back of the board there is space for smoothing capacitors to reduce power supply ripple. There is space for one through-hole ceramic capacitor and 4 1206 sized SMD capacitors. So let's add a 1 microfarad ceramic capacitor. Okay, now let's take a look at the voltage on the oscilloscope. In the comments of the previous video, quite a few people mentioned that these cheap regulators are not great. So let's check what voltage we're getting. While running Doom, we're getting a ripple of up to 500 mV. And once we stop it, the ripple drops to around 250 mV. The CPU is currently running at 66 MHz, so let's switch it to 100 MHz and see if there's any difference. And yeah, the ripple is much worse on idle. It is up to 900 mV. And if we run Doom, I think it's a little bit worse. And whoa, the game just crashed. But this is a bit strange, shouldn't a 1 microfarad capacitor be enough? Aha! I had accidentally installed a 104 capacitor, not a 105, so it was a 0.1 microfarad capacitor, so it was 10 times smaller. Anyway, let's see if it gets any better with a 10 microfarad capacitor. And yeah, the ripple is way smaller. And even in Doom, it does not go beyond a couple hundred millivolts. And if we zoom in to the megahertz scale, we can see that there is some ripple at around the 10 MHz frequency. Okay, let's finally try the 1 microfarad 105 capacitor, which I originally intended to install. I guess it seems to be good enough. But what is a good value for the smoothing capacitor? First of all, let's see what is the job of the smoothing capacitor. So let's say we have a power source that produces this output. The smoothing capacitor's job is to make the voltage more smooth, like what is shown in red. The difference between the highest and the lowest voltage points is the ripple. There is a formula for calculating the value of the smoothing capacitor. Capacitance equals current divided by 2 times the frequency times the ripple. In our case, the current should be around 2 amps, the frequency that we're trying to smooth out is around 100 kHz, and the desired ripple is around 0.1 volts. So a good capacitor value is about 100 microfarad. But this formula is for a rectified sine wave, but in our case the waveform is quite different from that. Anyway, if there is a better way to calculate the capacitance, please let me know in the comments. Oh, and by the way, the DX4 does not seem to be getting very warm even when running benchmarks, so I guess it can even run without a heatsink. Okay, that's all for now. The sources and the Gerber files for the socket blaster are available on GitHub. The link is in the description. This is a proof of concept prototype, so there's a lot of room for improvements and for new features. And of course, patches or pull requests are always welcome. Thank you for watching, and goodbye.